All right, welcome in. Happy Friday. I am Professor L, and I'm going to do this live stream for Math Help. So, no better time than a Friday evening to do some math. And what I did was, I'm really hoping I have sound tonight. I'm just going to work the problem that I started out yesterday working. And it's a trigonometry applications problem, and it's only it's not a right triangle, and it's only giving us the area, and it's giving us two angles known in the triangle. So let me go ahead and write this out real quick and see how it goes. It says the area of the triangle is 8,346 square feet, and two of its angles are and I'm gonna have to get another marker because this one's, where's my good marker? I'm separated in. All right. 37 degrees, 25 minutes. And let's see what this other one is and get these values up here. 56 degrees, 17 minutes. And if you are here and you are watching and you have a particular problem that you would like to see me put on the board, you are welcome to post that in the chat. And I have my volume turned up, so it should give me a notification. And I'll go ahead and work your problem next, or depending on how the problem goes, I might just stop this one and work yours instead. But we are going to be using two concepts in trigonometry. One of them is the law of sines, and the other one is this thing called Heron's formula. So Heron's formula was derived from laws of sines, and it's we're going to go ahead and write it on here, Heron. And this is generally introduced after laws of sines and laws of cosines, and it is involving the side lengths. So I think I at one time had it memorized. It's S minus A times S minus B times S minus C. And then there's another variation. I think that this is the one that we can use though. And I found another variation. I just realized it after I put Heron's formula up, and it's involving the sines of angles. So it says the area can be expressed in terms of any sides and angles. So that's the one we're going to actually need. We're not going to need this one. We're going to use a squared sine. What is it? I'll just carry this book over here with me so I can. And there's three of them listed, but I just picked the first one. They're all pretty much the same. Sine beta, sine gamma over 2 sine alpha. So we've got our Greek alphabet. All right, so what we're going to do is we're going to use this formula because K equals the area. So where K is the area. So we use this one. And we're going to use the fact that all three angles in a triangle add up to 180. So we're going to say we'll go 37 degrees 25 minutes and 56 degrees 17 minutes. And we're going to convert these to decimal, make it a little bit easier. $37.25, which, wait a second. That's wrong. It's 25. Okay. 37.416 repeat. And then 56 degrees and 17 minutes is 56.283. Repeating. And then what we're going to do is we're going to use the fact that all three angles adding up to 90 degrees or 180 will equal the triangle. So you've got 37.4, I will say 42 plus, hang on a second, I don't want to do that. We're going to get exact. So we're going to go ahead and add these. All right. So if you want to add these, you can add them regular. The only thing is when you get to 60 minutes, you have to make it another degree. So 5, I don't think we're going to get to 60 here because 25 plus 17 is clearly not 60. So we've got, let's see, that's going to be 2. 14. And then that's 4. And then let's see. 13. So we have 93 degrees and 42 minutes. And we're going to subtract that from 180. And we can go ahead and use a calculator. 180 minus 93 degrees, 42 minutes is 80. I'm getting 86 degrees in 18 minutes. And the decimal was 86.3. Okay, so we need that because the formula is involving all three, the sine of all three angles. So what we're going to do is we're going to take all three of these angles and this one, we can go ahead and round these if you want. We'll say 4.2. And then we'll say, we'll say 0.4. We'll go out to tenths place. How about that? 0.4. And what was that one? 0.3. Let's see this one again. 56 degrees and 17 minutes. So I'm getting 56.28. Yes, 56.3. Okay. I just wanted to make sure. All right. So, and this is the reason why we're choosing this route is because we have the area and we have two angles. And in a triangle, if you have two of the three angles unknown, you are fated to know the third angle because they all add up to 180. So in essence, they all add to 180. So we have this triangle. And we will call this angle A, this one B, this one C. So we have a little A, little B, and little C. So what we're going to do is, we know the total area is 8,346. And we know all three angles now, so we're going to box them. So we're going to first plug into Heron's formula here. We'll say a squared times the sine of beta. So we'll just say B is beta. So we can label these, we'll say A is 37.4, B is 56.3, and C is going to equal 86.3. So we'll label this one, we'll label it alpha. We can label this one beta, and then this one will become gamma. And so that's how we'll go ahead and plug them into the form. I like lists. It helps me stay organized. So we've got beta's 56. So 56.3 times the sine of gamma, which looks like it's 86.3, divided by 2 times the sine of alpha, which is 37.4. Okay, good. And then we'll plug in, I want to know, we're going to go ahead and plug in for the formula as well. The area equals 8,346. So what we're going to do is we're going to start by eliminating this denominator in the first step. So what I'm going to do is I'm going to multiply both sides of the equation by this value that's in the denominator here. So we'll have 8,346 times 2 sine 37.4. And that is going to equal, the denominator is going to go away, because you're going to multiply both sides by this whole thing. I can actually figure out what that value is. All right, so we've got a squared sine 56.3 sine of 86.3. And so we're going to divide off this value, sine 56.3 sine 86.3 to solve. So we'll divide both sides by that. Okay, so you're going to end up with a squared equals, because this is going to cancel, and then you're going to end up figuring out what this is, and is equal to a squared. And so for me, I will just type all this in the calculator. So I've got, I'm going to start out with sine 37.4, and I'm going to multiply it by 2. And then I'm going to multiply it by 8,346. And I'm getting 10,000. 10,138.3 0.1752, and that's going to divide it by all of this, and we'll just get a decimal. So we've got sine 56.3, sine 86.3, and oh, I don't trust it, so let me redo it. Sine 56.3. It's probably correct, but I'm going to multiply this times the sine of 86.3. It's like the same answer. Okay, I did. So we're going to divide it by 0.83022 and get an approximation for a squared. So let me type all of this in now. 10138.31752 divided by 0.83022000122. So I'm getting 12,211.6034. And then to solve for A, you just take the square root of both sides. So you get A approximately I'm getting A to be approximately 110.5. That's my hair right here. 5061238. Okay. Now that we have A, we have little a, and we have two angles, we can quickly use A to solve for those other two sides. We can't use Pythagorean theorem because that's only good for right triangles, but we can go ahead and take this approximation of A. This is 110.5, 10.5, and then we'll set up a ratio of law of sines. So we got law of sines to go ahead and get those others. So we've got sine A over little a equal sine B over little b. So let's go ahead and find sine of little, let's find side B using sine A. So A is 37, so it's going to be sine 37.4 over 110.5, and that's going to equal the sine of beta, 56.3, over little b. Use your cross product and solve for b. B is times sine 37 degrees 0.4 is going to equal 110.5 sine of 56.3. And then you're going to divide off the sine 37.4 to get your approximation for B. And I will put all that in the calculator and just put that right here. So let's see, 110 times sine of 56.3, and then 91.93, and we're going to divide that by the sine of 37.4. So I'm getting B to be approximately, it says 151.36597. We're going to round that to 4 because I'm out of room. So it's 151.365957. We'll just say 4. Right, and so then we're going to again use law of sines again. And it looks like I'm out of room because I wasn't organized. I wrote too big. So I'm going to go ahead and figure out where I want to put this. We're going to go ahead and use law of sines again. Just solve for C. Maybe I can just fit it in here somewhere. See if I can write small. So we've got sine of A. So I'm just going to say sine of what A is actually, because let's save room, is 37.4. And that's over side length A. And that's going to equal sine of C over side length of C. Little c. So sine C is 86.3. All right, so use your cross product again, and you'll get C sine 37.4 equal 110.5. Sine of 86.3. Divide off the sine of 37.4 on both sides. And you're going to solve for C here. Put that in there. C is going to be approximately okay, so we've got 110.5 sine 86.3. And I got 110 divided by sine of 37.4. And I'm getting 181.5509749. So I'll approximate that to be 181.6. So as soon as all 3 angles are known and all 3 side lengths are known, this is how you solve for a triangle. So these are the solutions for your triangle. These are your 3 angles, 3 side lengths, and we already knew the area. So there are no other values to be known, and so that's what they call, it's what they mean when they say solve the triangle. It's find all those other missing values. And yeah, so I feel like that was good, a good run. It took me a little bit longer than I anticipated, but I like it. I think reflecting on it so far, I feel like I probably started off writing a little bit big and wasting my board. I'm trying to learn to be more organized. So for that, I think that we'll go ahead and end the stream for tonight. And yeah, I'll just get on with my weekend festivities Friday night and got my math out of the way for the day. And we'll figure out what we're going to do next time. So if you watch my video, I very much appreciate it. Thank you so much. I appreciate all of the support. And again, I am Professor L, and I will see you next time. I'll be back on Monday, same time, same place. So I'm going to go ahead and sign off, and I'll say bye for now. See you next time.